Welcome students to another video lecture together. This one is chapter 3.4 of our textbook, Dividing Rational Numbers. And our essential question is, how do we divide rational numbers? And remember that at this year, we're focusing more on our use of fractions as rational numbers and less on decimals. So the homework will focus on fractions, but I do provide you the directions for decimals on this note as well, both of which are rational numbers. So pause right now and copy down what you see. Okay, welcome back from your pause. So we went over our essential question there. How do we divide rational numbers? And then I'm going to go 2 slides ahead so you can copy all the directions you need before I actually go on for the problems. Pause here. Excellent, back from another pause. Okay, so step 1, write all numbers as fractions or improper fractions. You'll notice 2 1/5 needs to be turned into an improper first. 2 times 5 is 10, plus 1 is 11. So right now we have 11 over 5 divided by -7/10. And really all we've done so far is rewritten the problem so it is all fractions or improper fractions. Step 2, we take the reciprocal of the number behind the division symbol. This is similar to when we turned subtraction problems into addition expressions. We're now turning division problems into multiplication expressions so that we can use our rules of multiplication on these problems. So the number behind the divided by symbol is -7/10, and its reflipical is -10 over 7. Pay attention to the fact that the sign doesn't change. Now on that same exact line, we're going to want to change the divided by symbol to a multiplication symbol. We don't want to do that over 2 separate steps. It's good to do that transformation at once. And now we bring the 11/5 straight down. And at this point, we start following our rules of multiplication. And you may remember that step 2 of multiplication was reduce. In division, it's step 4 because of the transformations we had to do first. So now we're starting to reduce, and that's any numerator with any denominator. So we have 5 and 10 in common. 5 divided by 5 is 1. -10 divided by 5 is -2. And I almost forgot, I should probably have some answers in my answer spot first. What is a positive fraction times a negative fraction going to get you? You are right, and if you didn't have an answer, check your 2425 note. This will be a negative fraction answer. And now that we reduced, and there are no reductions, we multiply straight across. 11 times 2 is 22. 7 times 1 is 7. And we just double checked that we reduced correctly. Yes, we did. That fraction is, in fact, in simplest form. So the answer is -22 over 7. And now let's try some other models. Okay, go ahead, write problem 1 down. And you may be able to write number 2 next to it, not below it. Pause here. Okay, welcome back. We're going to, just in case you had trouble reading that at all, I now realize it could be difficult. That was 4 over 3 divided by 16. So the first thing we're going to do is change these into improper fractions. We're following step 1. We got to get that over 1. Now step 2 says take the reciprocal of the number behind the divided by symbol. The number behind is 16 over 1, so we're going to take its reflipical and turn it into 1 over 16. At the same time, we're going to change our divided by symbol to a multiplication dot. And then we bring 4/3 straight down and follow our rules of multiplying fractions. We're able to reduce this 4 and 16 by the number 4, and that gets us our answer of 1/12. Nicely done. Okay, problem 2, I'm going to let us figure out in class. So we'll continue problem 2 in class. Great job writing it down though. And now just leave some space so we can get some room for these problems next. Oh my, those look really funny. You're going to want to pause here and write down that reflection question and go ahead and write down number 3 and number 4 next to each other, not on top of each other. Great job writing that all down. So what we call these are complex fractions. And really, complex fractions are just written really funny. And there's nothing different from fractions we normally divide. The fraction we read first, we're going to write first. Then this bar in between the two fractions stands for a divided by symbol, so we write a divided by symbol. And then 3/4 is the second fraction we read when we read this complex fraction, so we write it second. And now you should notice this problem looks a lot like our other problem. I'm going to do the same rewrite on problem 4 because I'm going to have you solve problem 3 and 4 in class. So before I substitute in problem 4, I'm going to rewrite it. So 5/8 is the fraction I read first, so I write it first. Then this bar in between is the divided by symbol, and then we write A because it came second. And that's how we rewrite these fractions. So then we're going to go over these in class. So leave some space here. We're going to model this in class together. So leave some space, and then we'll go on to the next problems. Okay, so write down problems 5 and 6 next to each other, not on top of each other. And what I'm showing in these problems is just because letters start showing up doesn't mean the skills change. So I'm going to model number 5 all the way through, and then we will do number 6 together. So step 1 says write all fractions as proper or improper fractions. Well, those are proper or improper as far as we know. Step 2 says take the reciprocal of the fraction behind the divided by symbol. And the reciprocal of 15 over ABC is ABC over 15. Notice the skill doesn't change. Then the next step is we change that divided by symbol to a multiplication dot, and then we bring the other fraction down. And now we're on the next step called reduce. And if you remember, reduction is just looking for the same thing on the numerator and the same thing on any denominator. I notice the numerator has an A and the denominator has an A. And A divided by A equals the number 1. So notice the skill works even on variables. We reduce the A's to the numbers 1. If you look closely, you may also notice there are more reductions we can make. Yeah, you're right, we could do the B's. B divided by B is also the number 1. Yeah, there is one more reduction. That's the 5 and the 15. What number do 5 and 15 have in common? You're right, that's the number 5. So 5 divided by 5 is a 1, and 15 divided by 5 is a 3. And now we've reduced as far as we can, and we just multiply straight across. So 1 times 1 times 1 times C is C. All over 3 times 1 times 1 times 3 is 9. That's the answer. C over 9 is in simplest form. Again, I'm going to have you do 6 in class. So now we're moving on. These are the last 2 slides of the note. So like I said, we're going to focus this lesson on fractions. But rational numbers still could be decimals as well. So these last 2 slides are going to give you the steps for dividing decimals. Please pause here, and then I'll go over it. Welcome back from the final pause of this lesson. So right now, we're going to place the dividend in the division house. The dividend is the number on top if you forgot. So we're going to put 5.86 inside the division house. And now we're going to place the divisor, the bottom number, on the outside. Step 3 says move the divisor decimal point until it's a whole number. Well, we have to move this once, so we have to make sure to be fair. If I move the divisor by 1 decimal place, I also have to move the dividend by 1 decimal place. And rather than get confused on this math problem that looks like it may have 4 decimal points, I'm going to rewrite the problem. So really that's just a 2 dividing into 58.6. So now we just perform our long division. 2 goes into 5 2 times. 2 goes into 18 9 times. And that hasn't terminated yet because we still have digits. 2 goes into 6 3 times. And now this problem has terminated. The answer is 29.3. Remember, if you have any questions, please write them in the questions section of this Cornell note, especially right next to the problem. This can help you with your studying later. So again, thank you so much for working with me on dividing rational numbers. I'll see you soon.